Inside your body, right now, are traces of at least 3,000 different chemicals that never appeared on any ingredient list. They are called food contact chemicals, or FCCs, a vast catalog of substances used to make the packaging that touches everything you eat. Think about the plastic wrap on your cheese, the lining of your canned soup, the carton for your milk, or the bottle holding your water. Each one is a complex material engineered to be stable, but that stability is not absolute. On a microscopic level, your food container isn't a solid, impenetrable wall. It's more like a dense forest of polymer chains. And through this forest, smaller, unbonded molecules, additives like plasticizers, antioxidants, and colorant, can slowly wander. This process is called migration. Heat, acidity, and fats in your food can act like catalysts, encouraging these molecules to leave the packaging and take up residence in your meal. It's a silent, invisible transfer happening in your fridge and your pantry. Once these chemicals are in your food, they become part of your diet. Your digestive system doesn't distinguish between a nutrient molecule and a molecule of bisphenol A from a can lining, or a phthalate molecule that made a plastic container more flexible. They are absorbed through the intestinal wall and enter the bloodstream, where they can travel to every organ in your body. These are not hypothetical journeys, they are measurable events. Scientists can find these packaging-derived compounds in blood, urine, and even breast milk. The problem is the sheer number and the unknown effects. A 2017 study by the Silent Spring Institute reviewed the vast list of these migrating chemicals. They cross-referenced them with databases of known and suspected carcinogens. The results were unsettling. Of the thousands of FCCs, 189 were identified as having the potential to cause mammary tumors in animals, making them potential human breast carcinogens. This list includes well-known families like perfluorinated compounds, or PFA, used for greaseproofing, and benzophenones used in printing inks on packaging. This raises a fundamental question. How can substances linked to cancer be in our food packaging? The answer lies in a regulatory blind spot. Many of these chemicals were approved decades ago, under a system that often tested for acute toxicity. Does it poison you immediately? Rather than long-term, low-dose exposure. Furthermore, the system often tests chemicals one by one, in isolation. It doesn't account for the cocktail effect, the synergistic impact of being exposed to hundreds or thousands of these different compounds simultaneously, every single day. So the boundary between your food and its container is not a fixed line. It is a porous, interactive membrane. The chemistry of the package becomes, over time, part of the chemistry of the meal. This redefines what an ingredient is. It's not just what the chef or the factory adds, but also what the container contributes during its journey to your plate. We are not just eating food. We are consuming a complex chemical echo of our industrial world.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.